All right, welcome back to 2.3. This is going to be part B, looking at the last three objectives here. So objective 5, use a graph to locate the absolute max and absolute min. Okay, so by definition, the absolute maximum and the absolute minimum are just the places in which the highest points of the graph are. Okay, so if you have a graph like the one that's pictured here, the absolute maximum, and really there's only one maximum here, so this is kind of a bad example, but this guy right here would be the absolute max because it is the tallest point on the graph. Okay, the absolute minimum here would be this guy because that point is the lowest point on the graph. So the absolutes are just the highest and the lowest points. You can have a ton of local minimum and maximums, right? Those are just mountain peaks and valleys, but these are like the highest peak, the lowest valley. This could also be, so an important thing to note here is these maximums and minimums, if you're looking at the absolutes, they can also be like the highest point on the graph, right? So you could have a graph that just goes like this. If you have something like this, the absolute max is this point here that's the highest point on the graph, right? So that's a little bit different in that way. Okay, so let's get into some of these. It says, for example 5, find the absolute maximum and the absolute minimum if they exist. Also find any local maxima or local minimum. Okay, so for this one, the absolute max is going to be the x value of the highest point. The highest point here is this guy. So the absolute max would be x equals 5. And I believe they'll want it as an x equals. Let me just make sure. Okay. Oh, they did the minimum first. But yes, it looks like they're wanting the x value. Just about every time they're going to want just the x value just to locate where these things happen. Okay, the local minimum would happen, in this case, notice that the minimum happens at a y value of 1. So if you wanted to identify where that is on the x, you'd have to say, well, it happens, for the local minimum, it would happen between 1 and 2, right? Between 1 and 2. Okay, so here it says the function has the interval 0 to 5. As its domain, the absolute max is f of 5, which equals 4. The absolute minimum is 1. Oh, okay, so cool. Okay, so they're just, if you ask for, so be very careful, you guys, because look, this might be a little bit confusing to you. Let me make it very clear right now. I am giving you the x locations of where these things happen. You need to read your directions and see if they're wanting the x locations or if they're wanting the actual minimum. So if it just says, give me the absolute minimum and it doesn't say anything about the x of where it happens, then they're looking for where that minimum happens in the y direction. So notice the absolute minimum happens at 1 because this in the y direction happens at 1. Okay, if it said, at what x coordinate does the absolute minimum happen? Then it would be this interval 1 to 2. All right, so that's the difference. Hopefully that makes sense. And then for the absolute maximum, obviously, they listed 4 because they're looking at the y values. But it happens at 5, right? It happens at x equals 5. But the maximum value in the y direction is the y value, which is 4. Okay, so hopefully that's not too confusing. So let's look. Let's keep looking here, and this kind of explains that too, that it happens on this interval in the x, if we're looking at x's. So let's look at theorem 2. This is actually an important theorem, kind of a common sense theorem. It's the extreme value theorem, which states if f is a continuous function, so if we have a continuous function, right, let's just draw one, something that looks like this, whose domain is a closed interval between a and b, so we can call that a, call that b. Okay, so if the domain is that closed interval between those two things, then f has an absolute maximum and an absolute minimum on that function. Okay, so here The absolute maximum would actually be whatever the y value is at this point, and the minimum absolute would actually be on this one, whatever the y value is at that point. Okay, so it's just saying if you have a closed continuous function on a closed interval, there's going to be a max, there's going to be a min. Okay, objective 6, use a graphing utility to approximate the local maximum and local minimum and to determine where a function is increasing or decreasing. Okay, so it says use a graphing utility to graph this function. I'm going to use Desmos. You guys are welcome to type that into your graphing calculators. If you look at Desmos, we're going to look for a couple of things. I'm going to pull it up here in a second. It says approximate where f has a local max, where it has a local min. Then determine where it's increasing, decreasing. Okay, so let's pull that function up. So I graphed that here, and I limited my graph. If you'll notice what I typed in there, I limited the graph between, because what's very, very important here, you guys, is we're only concerned with the interval -2 to 2. So we're only, on the x-axis, we're only looking between -2 and 2. This graph keeps going beyond those, but we're only looking at this picture of what happens in there. Okay, so I graphed it and I restricted it to that so that we can look at that. So here it is. They wanted to know what the local max and local minimum are. Okay, so at what x value does that happen, and then what are they? So if we look here, it happens at -0.816, and the local maximum, or maximum, would be 11.532. Okay, I just tapped on the graph, and it brought these points up. So you just tap on these, or click on them if you're on a computer. I'm on an iPad. The local minimum happens at 0.816 in the x, and then the y value at that minimum is -1.532. Okay, so we can take this information now, and we can tell that this graph is increasing from -infinity, okay, if you follow it from left to right, up to -0.816. Okay, so it's increasing there. Then it decreases from -0.816 down to 0.816, and then it increases again from 0.816 to infinity. So you'll see that now. Okay, I just talked about it. We just showed it to you. Let's look at where they actually give you the answers here for this. Notice. Here it is. Okay, so we're increasing from -2 to -0.82. Let's take a look at that. So we're increasing from, okay, so since we're only looking at the picture of -2 to 2, they've restricted it to -2, right? I called it -infinity, which is technically correct, but if we're only looking at this interval, then we would start with -2, and it goes to -0.82. Okay, then we go from -0.82 to 0.82. That is where we're decreasing, where the graph is going down. And then from 0.82 to 2, it's going back up. Okay, so it's from 0.82 to 2, it's increasing again. Okay, so there's two answers for increasing, because on this picture, you guys, to be clear, it's increasing in two places when you look from left to right. Okay, and only decreasing in one place. Okay, it's only going down in one place. So that's how you use a graph and the local maximum and local minimums in order to determine where a graph is increasing, where it is decreasing. Okay, objective 7, find the average rate of change of a function. This is actually a big deal in calculus, you guys. This is part of what goes into learning a little bit more about derivatives. We look more at tangent lines than secant lines, but it's very, very related to this idea. We're looking for an average rate of change of a function. So, don't let all this confuse you. This looks like a big mess here. All this is saying is we're going to plug in some x values on a function, and we're going to look to see what the average rate of change is between those two. Okay, so we're going to look at basically we're just going to look at the slope. The change in y over the change in x. Okay, what's the change in y over the change in x? So here it says find the average rate of change for this function, x squared plus 1, from 0 to 2 and from 1 to 2. Okay, so what they want us to do is they want us to plug in 2 for x and then plug in 0 for x and then subtract them to find the change in the y value. So if I plug a 0 in, it's going to give me a y value out, right? So if we do the math, if you plug let's just do both of them. So let's just plug a 0 in, 0 squared plus 1, and then we're going to plug a 2 in, 2 squared plus 1. Okay, if you do this one, you get 1. If you do this one, you get 5, right? So notice how they put this into practice here. They said, okay, if we plug 2 into the function, we get 5 out, right? That's what we did here. If you plug a 0 into the function, we get a 1 out. We're looking for the difference in them because it's the change in y. Slope is the change in y, so we always look for the difference. 5 minus 1 is 4. Okay, the change in x are just the change in the numbers that they give us. So it's just going to be 2 minus 0, which is 2. Okay, so the slope between these two places on the graph is 2. So that is the average rate of change. Then we look at from 1 to 2. Okay, so we do the exact same thing. Okay, so we put a 1 in, 1 squared plus 1, and then we put a 2 in, 2 squared plus 1. This is going to give me 2. This is going to give me 5. Okay, so the difference between 2 and 1 is just 1, right? You just subtract the x's, and then you subtract the y's. 5 minus 2 is 3. Okay, so the average rate of change between 1 and 2 is 3. So it's getting steeper. We see that it's getting steeper in this part of the graph than it was in this part of the graph. So that's how you find the average rate of change. Theorem 3 says the slope of the secant line. The average rate of change for a function from a to b equals the slope of the secant line. That's all we've been doing, you guys. This is just a slope, right? That's all this is saying, is that you can take 2 points, find the slope of the line between the 2 points, and that will tell us the average rate of change of the function between those 2 places. Okay, the slope of this line tells me the average rate of change of that curve. So example 8, and then we'll be done. Okay, so example 8, I think I might have one more, but it says suppose that g of x equals x squared minus 3x plus 2. It says find the average rate of change of g from 1 to 3. Okay, so we know that this is change in y over change in x. So they give us the x values to plug in. So we can say 3 minus 1. So we know that the change in x is going to be 2. Okay, then let's actually plug those in. So if I plug a 3 into this function, 3 squared minus 3 times 3 plus 2, we get 9 minus 9, which is 0, plus 2, which is 2. Okay, so if I plug a 3 in, I get 2. If I plug a 1 in, 1 squared is 1, minus 3 times 1 is 3. So 1 minus 3 is negative 2. Negative 2 plus 2 gives me 0. Okay, so I get 2 minus 0, which is 2. 2 over 2 is just 1. So the average rate of change from 1 to 3 is just 1. So it says, then find an equation of the secant line containing 1 comma g of 1 and 3 comma g of 3. Okay, and then use a graphing utility to draw the graph of g and the secant line obtained. All right, so now I know my slope, you guys. My slope between these is 1. So if I'm going to put this into, well, let's see how they do it, but you could put this into just slope-intercept form. You know that it would be y equals x plus b, and you'd have to determine b by plugging in an xy combo. Let's see if that's how they do this. So notice they got 1 for their slope like we did. Okay, and then for this, okay, they use the point slope form, which is fine. So we know one of our points, right? If I plug a 1 back in to the function, it'll give me g of 1. When I plug a 1 into this function, I got 0. right? So I know that one of my points is 1 comma 0, and I know my slope is 1. All right, so to find this out, what I'm going to do is I'm going to use my point slope form. Okay, so I have y minus y1 equals m times x minus x1, right, where I know an x and a y. So this would be y minus my y1, which is 0, equals 1 times x minus x1, which is 1. Okay, so y minus 0 is just y. Y equals x minus 1. So there's my equation for my line. And I believe they want us to just graph that. So you would graph the line y equals x minus 1, graph the original function. You can do this on your graphing calculator. You can do this on Desmos. But they just want to see that you're able to do that. All right, guys, that's it for part B. Sorry for the long lesson. We'll catch you guys next time.